Assume that a sample is used to estimate a population mean mu. Find the margin of error that corresponds to a sample size of 20 with a mean of 37.9 and a standard deviation of 15.4 at a confidence level of 90%. Report the margin of error accurate to 1 decimal place because the sample statistics are presented with this accuracy. The answer should be obtained without any preliminary rounding. However, the critical value may be rounded to 3 decimal places. Okay, so to come up with a margin of error, the first thing that we need to note here is the value that we're estimating is the population mean, because it says here we want to estimate the population mean. So that gives us a set of formulas that we need to work with. So the formula for coming up with a margin of error for a population mean. Margin of error is a critical value based off of a distribution. And here we do need to be careful. We have a small sample. So we have a sample of size 20. And when you have a sample of size 20 that's less than 30, unless you know that your distribution is normal to begin with, you can't really assume that the central limit theorem is going to result with a normal distribution value. It's safer here to use a t distribution. So I'm going to call this a critical value based off of a t distribution times the sample standard deviation divided by the square root of the sample size. Now, this critical value based off of a t distribution, we get it in the same way that we get a critical value based off of a normal distribution. It's just that we have to use the different distribution, that's all. So it's the absolute value of the inverse t of 1 minus the level of confidence divided by 2. That's the same from inverse norm. But t distributions, you also have to provide a number of degrees of freedom. So the number of degrees of freedom is just 1 less than your sample size. So in this case, the degrees of freedom would be 19. So what it's going to look like is inverse t, 1 minus a level of confidence, which is 0.9, divided by 2, comma, 19. And again, that's because if your sample size is 20, your degrees of freedom is 1 less than your sample size, and that's why I'm using 19. So in the calculator, to get this, what we need to do is second distributions and come down to inverse t. And maybe not all of you actually have inverse t distributions. If you have one of the earlier model TI-84s or a TI-83, you very likely don't. So I'll show you in another way how to come up with the answer to this question. But let me continue like this first, for those that do have this function. The area, so this is going to be the 1 minus 0.9 divided by 2. So 1 minus 0.9 is 0.1, and when I divide that by 2, that's 0.05. The degrees of freedom is 19. When I paste that, just use inverse t, and I come up with 1 point. It's said to use 3 decimal places for the critical value, so, and I'm making it positive for the absolute value. So 1.729. So this will be 1.729 times the standard deviation, which was given as 15.4, and divided by the square root of the sample size. And we'll make sure you're not using the degrees of freedom again. You actually are using the sample size here. Now, when it said not to use any preliminary rounding, a really easy way to make sure you're not is to just take that value and then just hit multiply. You will have a negative of the answer that you're supposed to get, but you can actually take care of that. Just say multiply that by -1. All right, now you're using all the decimals instead of just 1.729. So it's up to you. It probably doesn't make a whole lot of difference in the final answer, but the problem did say not to use any preliminary rounding. But if you do, then use 1.729. All right, so we get 5.95. And it said to report your margin of error accurate to 1 decimal place. Well, if I round this to 1 decimal place, the 5 is going to round the 9 up, which makes this 6. So effectively 6.0. Now, for those of you that didn't have the inverse t function, there is another function in the calculator. If you hit the stat button, go over to tests, and you come down to t interval. So this function will calculate a confidence interval for you. And basically, if you get the confidence interval first, you can come up with the margin of error from that. Let me show you how that's done. So switch over to stats mode. If you have an actual data set to begin with, you would select data, but here we just have stats. The mean of our distribution is 37.9. The standard deviation was given as 15.4. And the sample size was 20. The level of confidence we were interested in was 90%. Now when we hit calculate, we certainly don't get anything resembling 6 here. But let's take the endpoints of these intervals and let me write them down real quick. All right, so 43.854 minus 31.946. So what that does is it gives you the width of your confidence interval. And the width of your confidence interval is twice the of your margin of error, because to come up with your confidence interval, you take your sample mean and you add and subtract the margin of error, which is 2 times your margin of error. So if you subtract the endpoints of your confidence interval and then divide by 2, then you can get the margin of error that way. So again, we've got 5.95, which would round to 6. Either way works fine.